Hello and welcome to the 109th IUVSTA workshop, the APPEC Technology Forum Vacuum Cryogenics, where industry meets academia. Today, we will have a short teaser by Keith Middleman from ASTEC, one of our invited plenary speakers.
My name is Keith Middleman. I'm from ASTEC at STFC Daresbury Laboratory in the UK, and I'm going to talk to you about vacuum developments at Daresbury Laboratory for modern accelerators. Our group has got quite a unique position in that we have our own in-house accelerator called Clara, but we do a lot of conventional research in many aspects of vacuum technology. We look at new research and developments on various new technologies that could be implemented for accelerators. And also we deliver large scale infrastructure to international collaborators as well for some of their accelerators around the world. So we've got a unique set of skills in terms of vacuum, material surface science, etc. And that kind of puts us in a nice position. We deliver a lot of international projects. So I'll just tell you a couple of those. So we've done a lot of work for the European Spallation Source, designing all of their Linac warm units, sort of like detailed in this slide here, all of the engineering design, all of the vacuum design, and all the build and particle control elements required to do that. So we've delivered all of this to ESS now. We're also working, and we have finished now all of the deliveries for the superconducting, high beta superconducting modules, cryo modules for the European Spallation Source. We completed that earlier this year. So all of those processes have now been qualified, and they have now been shipped to ESS. We're doing some work with CERN on the high Lumi crab cavity, which is another SRF type cavity, to increase the number of collisions for the high luminosity upgrade. We've already built a prototype shown on some of these images here that's been shipped over successfully to CERN, and we're now in the process of building the next 4 crab cavities as we speak. So that's obviously some of the work that's going on at the moment. And one of our other main collaborations is with PIP2. PIP2 is the Proton Improvement Plan at Fermilab in the US, where we have to deliver 3 complete cryo modules that each contains 6 individual SRF cavities, as shown in this image here. So there's obviously a lot of detail that's involved in that, and we're well under the way with this program. We've received the first cavities for testing, and as I say, we're starting to implement some of those processes and procedures in readiness for build. So as well as the work that we do for international partners, we've got a lot of work on research and technology for future accelerators. One of the primary areas that we've been working on for many years is neg coating. We've got lots of different areas that we've been looking at for this particular neg coating and its properties. Each of the bullet points listed here, we've got obviously a lot of detail that I would show at the actual meeting itself in more detail. We're also working with laser ablated surface engineering, which is basically used for potentially reduction of the secondary electron yield on some accelerators. So the idea behind this technique is basically where you take a sample and you modify the surface structure with the use of lasers. So you can see in this image here on the top left, we have a conventional copper, untreated copper sample, and one that's been treated by this laser ablated surface engineering. And that basically reorders the surface layers and allows us to reduce the secondary electron yield by applying this technique. So there's obviously a lot of work that we've done in this area as well, with a lot more detail to be presented at the meeting. And then finally, one of the other things that we're doing is some work on superconducting RF thin film research. So obviously bulk niobium has been around for a long period of time and it's extremely expensive. And what we've been trying to do is find an appropriate superconducting thin film that we can deposit on a different substrate, something like copper, which is obviously much cheaper than niobium, and see if we can actually generate some of the required RF parameters needed for operation in an accelerator environment. So we've had some success doing this with a variety of different deposition techniques, and we're currently in the process of depositing a single cell cavity, and that single cell cavity will be tested by the spring of next year. And obviously we aim to publish the results and obviously detail what those results are. So this is part of a wider European collaborative work that we've been doing as well. So
thank you for listening to the short introduction to topics of our 109th IUVSTA workshop. And we hope we can welcome you in Maastricht at the meeting on November 24 to 26.